All right, let's talk about what it means to solve an equation, because that sounds really fancy and complicated, but it's not really. All it means is to solve an equation, find the number that we could replace the letter with to make it true. And here's an example of one that looks really simple. What number does the x have to be for this to be true? So x plus 3 equals 5. Well, we can see just by looking at that to make this true, that has to be a 2, because 2 plus 3 equals 5. So we would say the solution is x equals 2, and you've solved it. We've worked out that we could replace the x with a 2 to make this true, because 2 plus 3 equals 5. That's all it is. To solve an equation is to find out a number value for the letter. And we could do that one just by looking at it, but for ones that are a bit harder and a bit complex, I'm going to show you a process of how we can do it. And we'll do this easy one again, even though we could just do this by looking at it. But let's go through the process. So let's do that one again. If I was asked to solve this equation, x plus 3 equals 5, what I want to do is I want to end up with the x on its own. That's what I'm aiming to do. What is the value for x? So I can see that there's some stuff around here attached to the x that I need to get rid of. In fact, the bit that I need to get rid of is this bit here. I need to get rid of this plus 3. So how do I do that? Well, we get rid of something by doing its opposite. So the opposite of plus 3 is minus 3. Because if I've got 3 and I take 3 away, I've got nothing left. It's gone. I can do whatever I want to one side of an equation so long as I do the same to the other side. So if I'm going to take 3 away from this left-hand side, I have to take 3 away from the right-hand side. It's like a seesaw. It keeps things in balance. So let's have a look at how does that help me solve it. Well, that bit's gone now. That's just sort of wiped itself out. So now I've got what I'm trying to achieve. I've only got an x left on this side. And on the right-hand side, I've got 5 minus 3, which is 2. And if you have a look, that's exactly what we got just by looking at it. So we solved it this time, but we used a little bit of a process. Let's do one more example for you before we look at a couple of different types of questions you might get. Solve x plus 13 equals 21. Now, in fact, let's do x minus 13 equals 21. Right? Remember, my goal is to get x on its own. So to do that, I have to get rid of this minus 13. What's the opposite of a minus 13? Well, it's plus 13. But if I do plus 13 here, I have to do the same on the other side. I can do whatever I want as long as I do the same to both sides. Now, the beauty of that is that wipes itself out. Those 13s are now gone, and I'm just left with the x on its own, which is perfect. That's what I'm after, x on its own. On the right-hand side, I've got a 21 plus 13. When I add those together, I get 34. So my solution is x equals 34. And this is what we call a one-step equation, because you see in these two examples, it only took us one step to solve it. We only had to make one little adjustment to get our solution. And I'm going to show you a couple of other one-step equations, because we've seen how to deal with pluses and minuses, but what about times and divide? All right, so let's look at this one. Solve 3x equals 12. Okay, it's an equation. My goal here to solve this is I want to get the x on its own. So that's what I'm trying to achieve. So how do I get rid of this 3? Well, this isn't a plus or a minus. We know that this is a times, because a number and a letter next to each other means times. So this is 3 times x. So think about it. What's the opposite of timesing by 3? Hopefully you know it's dividing by 3, because dividing and multiplying are the opposite operations. So if I want to get rid of a times 3, I have to divide by 3. But remember, what I do to one side, I have to do on the other side. Now, how does this help me? Well, we've got a fraction here that's got the same number on the top and the bottom, so they cancel each other out. And you'll see what's left is the thing I'm trying to get to. The only thing that's left on the left-hand side now is the x. Perfect. What's on the right-hand side? Well, I've got 12 divided by 3, so we happen to know that that is 4. So our solution, and we solved this once again in one step, we only made one adjustment to get a value of x equals 4. Let's look at one more of those. Solve, let's go with minus 5m equals 20. All right, I want to get the m on its own. I've got a times by negative 5 here, so the opposite is divide by negative 5. But what I do on one side, I have to do to the other. The negative 5s cancel out, and I'm just left with my m, which is perfect. And on the right hand side, I've got 20 divided by negative 5. If you're not sure, or you're not comfortable with the negatives, put that in your calculator and you'll get an answer of negative 4. All right, what about solving something that has division in it? All right, this is the last kind of variation we're going to look at. Solve x over 4 equals 2. All right, nothing's changed in terms of my goal. My goal is to get the x or the letter on its own. But in this case, I've got a fraction, which I know means x divided by 4, because that's what a fraction is, top divided by bottom. So what's the opposite of dividing by 4? Well, the opposite of dividing is times. So I'm going to multiply this side by 4, but what I do on one side, I have to do to the other. And the reason I've done this is I've now got number on the top and bottom that cancel out because they're the same. So it leaves me with my x on the right hand side, which is perfect. That's what I'm after. On the right hand side, I've got 2 times 4. So the solution to that one is x equals 8. Let's look at another one. All right, let's solve m over negative 2 equals negative 10. Remember, my goal is to get a value for m on its own. So I've got a divide by negative 2. The opposite of dividing by negative 2 is times by negative 2. But remember, what I do on one side, I have to do on the other. They cancel out because I've got the negative 2 on the top and bottom, which is perfect. That leaves me just with my m here. And on the right hand side, I've got a negative 10 times a negative 2, which I know works out to be a positive 20. And if you're not sure, you can do that in your calculator. 2 negatives make a positive. 10 times 2 is 20. So my solution is m equals 20. And once again, I did them in one step. So we say they are one-step equations. So we looked at solving a one-step equation where we had to add or subtract a piece to solve it. We looked at one where we had to divide to solve it. And then these ones we just looked at where we had to multiply. So we had to do the opposite. All right, good job. Well done.